coolant in, everything, and we got it up to speed, but we did have some warning lights on the dashboard that we need to get off. We've got the airbag light due to one thing, which we think is the pyro fuse, but there's two pyro fuses on here. One, we've learned, cuts the power to the start.
The workshop was finally quiet after hours of noise, sparks, tools dropping on the floor, and mechanics moving around a damaged Bugatti Chiron. The car that many people on the internet believed would never drive again was slowly coming back to life piece by piece. The cooling system had been rebuilt. The electrical systems were being checked carefully. Warning lights still glowed on the dashboard, but compared to how destroyed the car looked after crash, the progress already felt unbelievable. Mat Armstrong stood near the front of the car, looking at the dashboard, while discussing the remaining problems with the team. One issue continued to appear over and over again, the airbag warning light. At first, this looked like a normal electrical issue that happens after major accidents. Modern supercars are filled with sensors, modules, crash systems, and safety circuits that all need to communicate perfectly with each other. If even one component reports the wrong signal, the dashboard lights up immediately. But as the team continued checking the system, they discovered something nobody expected. Hidden inside one of the most expensive hypercars ever made was a part from a Mercedes Sprinter van, not a custom Bugatti component, not a rare hypercar-only system. A part from a commercial delivery van that millions of people see every day on roads carrying boxes and parcels. The discovery instantly created shock because people imagine Bugatti as a company that designs every small piece specially for its multi-million-pound cars. Most viewers assume every screw, wire, sensor, and safety system inside a Bugatti must be unique and expensive. But reality inside the automotive world works differently. Hypercar manufacturers often share parts with other brands because creating completely custom systems for extremely low production cars would cost unbelievable amounts of money. Still, hearing that a Mercedes Sprinter component existed inside a Bugatti Chiron sounded almost impossible. The surprise became even bigger when Matt explained that the part was connected to a critical safety system called a pyro fuse. This was not some hidden interior switch or an unimportant plastic bracket. It was part of the crash safety system designed to protect the car and the people inside during serious accidents. Suddenly, the story became larger than just a rebuild video. It became a look into how the hypercar industry truly works behind the scenes. The more the team investigated the problem, the more interesting the situation became. The pyro fuse appeared damaged, but there was confusion because the airbags had deployed during the original crash, while the fuse itself had not fully reacted the way engineers expected. Matt explained that on many Volkswagen Group cars, including Lamborghinis and Audis, these pyro fuses normally disconnect power after a crash automatically. But on this Chiron, something unusual had happened. The airbags fired correctly, yet the electrical system still had power. That meant the safety logic either failed or behaved differently than expected. The mystery immediately increased curiosity because viewers now wanted answers to several questions at the same time. Why was there a Mercedes part inside Bugatti? Why did the pyro fuse not activate properly during the crash? And why could such a tiny component delay the entire project from receiving a legal UK number plate? This combination of luxury, engineering, danger, and mystery transformed a simple repair issue into one of the most interesting moments in the entire Bugatti rebuild journey. To fully understand why this small component became such a massive problem, it is important to understand what a pyro fuse actually does. Most normal drivers have probably never heard the word before, even though modern vehicles quietly depend on these systems for safety. A pyro fuse is designed to protect the vehicle immediately after a serious collision. During a crash, modern cars must deal with more than damaged body panels and broken glass. They also face electrical dangers. A powerful car battery still contains huge amounts of stored energy after impact. If damaged wires touch each other or metal parts inside the vehicle, dangerous short circuits can happen very quickly. Short circuits create heat, and heat inside a crashed car can become extremely dangerous if fuel lines are damaged or fluids are leaking. This is why modern engineers develop pyro fuses. The system acts almost like an emergency shut-off device. The moment crash sensors detect a major impact and airbags deploy, the pyro fuse receives a signal to activate. Inside the component is a tiny explosive charge. When triggered, it physically cuts the electrical connection between the battery and critical systems inside the car. This is not just an electronic switch turning off power softly. It is a physical break in the circuit designed to stop electricity instantly. That immediate disconnection lowers the chance of electrical fires after crashes. In many ways, pyrofuses became one of the hidden safety technologies that quietly improve survival rates in modern accidents. People often focus on airbags, seatbelts, and crash structures because those systems are visible and easy to understand. But many invisible systems work together during collisions. The pyrofuse is one of those invisible protectors. The Bugatti Chiron actually uses two separate pyrofuses. One controls power connected to the starter system, while the other can disconnect a larger electrical network inside the car. According to Matt, both should have activated during the original crash because the airbags definitely deployed. But strangely, they did not behave normally. This created confusion because engineers expect these systems to operate together. If airbags deploy, pyrofuses usually activate too. The fact that this did not happen suggested either a fault, a special Bugatti calibration, or unusual crash conditions during the accident itself. Matt even joked that perhaps it was more convenient because the car could still be moved afterward. But behind the joke was an important point. A hypercar with severe crash damage still had live electrical systems because the pyrofuses failed to disconnect power properly. That discovery added another layer of engineering mystery to the rebuild. It also increased the importance of replacing the faulty unit correctly. A pyrofuse is not something cosmetic like a trim piece or decorative panel. It directly affects vehicle safety inspections and road legality. If the airbag system reports faults connected to pyrofuse, inspectors can refuse to approve the car for road use. This meant that one relatively inexpensive component now stood between the rebuilt Chiron and legal registration. Suddenly, the future of a multi-million-pound project depended on a safety device most people never even knew existed. The biggest shock for viewers came when Matt revealed the manufacturer of the pyrofuse itself. Instead of carrying a Bugatti logo or a special hypercar part number, the component traced back to Mercedes-Benz, specifically a Mercedes Sprinter van. This discovery perfectly exposed a hidden truth about the automotive industry that many people outside the car world do not understand. Luxury car companies, even brands as legendary as Bugatti, frequently use shared parts from larger manufacturers. At first, this sounds disappointing because people imagine ultra-expensive vehicles as completely custom machines designed from the ground up. But the reality of engineering and manufacturing is much more practical. Bugatti produces extremely limited numbers of cars every year. In some years, production numbers are only around 40 or 50 vehicles. Creating fully unique versions of every small safety component for such tiny production volumes would be financially impossible, even for a company selling multi-million-pound hypercars. Safety systems like pyrofuses require years of engineering, testing, crash simulation certifications, and reliability checks before they can legally enter production. Developing those systems from scratch for only a few dozen cars would make each part unbelievably expensive. Instead, manufacturers rely on proven components already tested by larger companies. Mercedes-Benz builds millions of vehicles and spends enormous amounts of money perfecting safety technology. Their pyrofuse systems are reliable, mass-produced, and fully tested under strict global safety standards. From an engineering point of view, using an existing Mercedes system inside a Bugatti actually makes sense. The physics of electrical safety during crashes are the same whether the vehicle is a delivery van or a 300-mile-per-hour hypercar. The component must disconnect power within a certain amount of time and under specific crash conditions. If the Mercedes part already performs perfectly, there is little reason for Bugatti to redesign the same technology from zero. Matt's rebuild had already uncovered many examples of shared automotive parts before this discovery. Various components inside the Chiron trace back to Audi, Volkswagen, Porsche, and Lamborghini. This should not be surprising because Bugatti exists within the larger Volkswagen Group family. Large automotive groups often share engineering resources and components across multiple brands. A hidden sensor from an Audi or a fuse board from a Lamborghini may work perfectly inside a Bugatti because the systems are related behind the scenes. The real value of the Chiron comes from the unique engineering that combines these components into one extraordinary machine. The W16 engine, the advanced aerodynamics, the carbon fiber structure, the cooling systems, and the high-speed stability all require enormous engineering investment. Those are the areas where Bugatti creates uniqueness. But for smaller systems like safety modules, sensors, and electrical hardware, using proven parts from larger manufacturers is simply smart business. Still, for many viewers, the idea remained fascinating because emotionally it feels strange to connect a luxury hypercar with a delivery van. The contrast creates powerful curiosity. A vehicle costing millions of pounds contains a component from something used to deliver packages around cities every day. That contrast became the emotional center of the entire story and helped the video capture so much attention online as if discovering the Mercedes component was not surprising enough already. The story became even more dramatic when Mat sourced a replacement unit and realized he had accidentally purchased a faulty pyrofuse from a crash van. On the surface, the replacement looked completely correct. It matched the model year, the specifications, and the physical design needed for Chiron. Mat and the team carefully prepared the installation process, opening the old unit and transferring the important internal components with precision. They soldered connections carefully, added heat shrink protection, and installed everything into Bugatti, expecting the warning light finally to disappear. But when the system powered back on, the airbag warning remained active. The frustration inside the workshop immediately became obvious. After all the effort spent tracking down the part, performing the installation, and testing the system, the problem still existed. Mat quickly realized something was wrong with the replacement itself. Then came the shocking conclusion. The pyrofuse had probably already been activated during the crash of the original Mercedes Sprinter it came from. That meant the explosive safety charge inside the component had already fired previously, making the unit effectively useless. From the outside, however, it looked normal. That is one of the biggest problems with pyrofuses in the salvage industry. Once fired, many of them show almost no visible external damage. The housing remains intact. Connectors still appear normal, and the unit can easily be mistaken for a working component unless tested properly. Mat joked that they had been scammed, but the truth was more complicated. The seller may not even have known the part was unusable. Salvage yards process huge numbers of crash vehicles every day. Parts are removed, cataloged, stored, and sold quickly. A pyrofuse from a crashed vehicle may simply be labeled as a pyrofuse without detailed information about whether it activated during the accident. This creates a major challenge because buyers may unknowingly purchase safety components that already performed their intended job once before. The entire situation highlighted a hidden weakness in the global automotive recycling system. Modern cars contain increasingly advanced safety technology, but documentation around those components inside salvage operations often remains incomplete. A fired pyrofuse can easily move through inventory systems unnoticed. For Mat's Bugatti rebuild, this mistake created another frustrating delay. The replacement had to be sourced again properly from a confirmed undamaged vehicle. What made the situation even more painful was how small the actual component was compared to the scale of the project. The rebuild involved massive structural repairs, custom fabrication, expensive carbon fiber work, complicated cooling systems, and advanced electronics. Yet after overcoming all those giant obstacles, the project became delayed by one small safety fuse from a crashed van. That contrast perfectly captures the unpredictable nature of rebuilding modern supercars. Sometimes the biggest problems are not engines or chassis repairs. Sometimes they are tiny hidden electronic components that control whether safety systems communicate correctly with the car's computer network. The reason this small pyrofuse issue mattered so much was because the Bugatti still needed to pass an IVA inspection before it could legally drive on public roads in the United Kingdom. IVAs stand for Individual Vehicle Approval, and it is an extremely important process for heavily rebuilt, imported, or modified vehicles. Inspectors carefully examine the car to confirm that it meets road safety standards. This includes checking lighting systems, structural integrity, electronics, emissions, warning indicators, and safety equipment. For a rebuilt Bugatti Chiron, the inspection becomes even more serious because of the vehicle's complexity and value. Modern cars constantly monitor themselves through dozens of sensors and control modules. If the airbag system reports any active fault code, inspectors immediately know the safety systems may not be functioning correctly. That alone can fail the inspection. This meant the glowing airbag warning light on the dashboard was not just an annoying symbol. It represented a legal barrier stopping the entire project from moving forward. Matt explained that the airbags themselves were not the issue anymore. The crash sensors were not the problem either. The warning existed because the replacement pyrofuse was reporting incorrect resistance values inside the electrical circuit. In simple terms, the car's computer believed something inside the safety system was still faulty. Until that signal disappeared completely, the Chiron could not pass inspection confidently. The frustrating part was that Matt was already preparing to leave Miami before the correct replacement unit could arrive. Time pressure added more stress to the situation. As a temporary solution, the team reinstalled the original fuse carefully just to keep moving forward with testing and preparation. But everyone understood that the final permanent fix required a proper undamaged pyrofuse from the correct Mercedes Sprinter model. Another fascinating detail emerged during this stage of the rebuild. Pyrofuses cannot easily be tested in a real-world way without destroying them. The only true proof that a pyrofuse works perfectly is seeing it activate during an actual crash. But once activated, the unit becomes unusable. Because of this, technicians rely mainly on electrical resistance measurements and diagnostic communication checks. If the component reports correct values, engineers assume it is functioning properly. That means safety systems often depend heavily on trust in manufacturing quality and proper sourcing. This is why buying safety parts from reliable suppliers matters so much. A single unknown component from a damaged vehicle can create uncertainty throughout the entire system. In Matt's case, the wrong pyrofuse delayed registration for a multi-million-pound hypercar. But the same issue could happen to ordinary vehicles as well. A family van, a daily commuter car, or a luxury sedan could all experience similar problems if incorrect salvage safety components entered the repair process. This broader lesson made the Bugatti story feel surprisingly relatable. Beneath the extreme price tag and hypercar engineering, the Chiron faced the same real-world repair challenges as normal vehicles. Faulty parts, salvage confusion, electrical diagnostics, and inspection requirements affect every level of the automotive world. One reason this story connected so strongly with audiences online is because it completely changed how many people think about hypercars and luxury engineering. Most viewers imagine vehicles like the Bugatti Chiron as magical machines built entirely from exotic custom components unavailable anywhere else on Earth. Marketing from luxury brands often supports this image by focusing on handcrafted details, advanced engineering, and extreme exclusivity. While much of that image is true, the pyrofuse discovery revealed a more realistic side of automotive manufacturing. Even the world's most expensive performance cars depend heavily on shared industrial systems and practical engineering decisions. The Chiron still contains extraordinary technology. Its quad-turbocharged W16 engine remains one of the most ambitious automotive power plants ever created. The car's cooling system, capable of managing enormous heat under extreme speeds, is incredibly advanced. Its aerodynamic stability at more than 300 miles per hour requires world-class engineering knowledge. None of that changes because a pyrofuse came from Mercedes-Benz. In fact, the discovery almost strengthens respect for the engineering process because it shows how intelligently manufacturers balance uniqueness with reliability. Instead of wasting millions developing a custom pyrofuse that performs exactly like an existing Mercedes system, Bugatti focused resources on the parts of the car that truly needed innovation.